All right, let's finish up the two-dimensional figures. So we did all that stuff with what? Triangle, quadrilateral, pentagon, hexagon, and all that kind of stuff. Now we're going to get a little bit more into it. We've talked about that word polygon. In fact, I think it was probably the first thing we talked about yesterday, what a polygon was, but we never talked about how to label a polygon. So let me do this. All right. I think that automatically comes up like that. How many sides is that? 1, 2, 3, 4, 5, 6. So what do we call that thing right there? It's a hexagon. Good. All right. And we didn't talk about how to name the hexagon. We did talk about these being line segments, right? And connecting at that point. We talked about that point is called. What is that point called where they come together? It's the vertex. What do we call the line segments themselves? Somebody get the door, please. What do we call that? The sides, right. They're the sides of the polygon, that particular polygon, okay? What we're going to do is we're going to learn how to name the polygon, okay, to label the polygon, all right? So watch. We'll call this A, B, C, D, E, and F, all right? So there's all the vertices, right? That's a plural of vertex. There's all the vertices, and if we were to name this thing, there's no symbol that you're going to use, except for when we get to triangles. I don't think we've done a triangle yet, have we? No, because we just talked about triangles. So there is a symbol for triangles, but really I think that's the only polygon that you actually have a symbol for. So if I wanted to name this, you could name it two different ways. You could call it polygon, and then whatever we're going to call it, or you could call it hexagon if you wanted to. In my notes, I just wrote polygon. So let's just write polygon. And what you're going to do is you're going to start with any letter. It doesn't have to be A. All right, just because A comes first in the alphabet, that makes no difference in geometry. It doesn't matter what comes first in the alphabet. We could start at A, but what you have to do when you name this thing, start at any point. It doesn't matter what point you start at, but you got to go to the next consecutive. Consecutive means the one right after it, all right, to the next consecutive point. So if I start at A, I could call it two different things if I start at A. So if I call it polygon A, whatever, what I'm going to do is just list all the points that are on that polygon. Now, it would be kind of dumb if you had a 100-sided polygon and you wanted to name it, right? That'd be kind of hard. We only got 26 letters of the alphabet anyway, so that'd be kind of tough. But for this, it's only 6 sides, so we're going to put 6 things here. So I could call it, and I got to go in consecutive order, the one that's right next to it. I could go A, B, or I could go which direction? A, F. It doesn't matter. It makes no difference. And I don't have to start at A, right? But we're just going to make this super easy and go in alphabetical order. Is that all right? So you could start at F if you wanted to. But we're going to start at A. I'll put a little X right there. Okay, we're going to start at A, and let's go this way. So what would I call this polygon? Polygon what? A, B, C, D, E, F. Doesn't exactly roll off the tongue, does it? All right, but that's what we would call that thing. Polygon, A, B, C, D, E, F. All right? You could go the other way. You could call it polygon what? A, what? Go the other way. A, F, E, D, C, B. You could call it that. Right. There's a lot of combinations that you could call it, couldn't you? You could start at B and go this way. Or you start at B and go this way. All right. It doesn't matter. It does not matter. All right. You're not going to see that a whole lot, but just got to make sure. Can you call it A, D, C, B, F, E? No, because that's not consecutive. We're going to use that word consecutive quite a few times throughout this course. So what does it mean to be consecutive? One right after what? Another. Okay, one right after the other. So the ones that are next to each other. So A and B are next to each other. That's a consecutive point. Everybody got that? All right. Let's see. What else do I want to talk about? Let's do this. So now I'm going to change colors. Now what I'm going to do is I want to make a line segment and connect 2 vertices together. But I'm going to connect 2 non-consecutive vertices. What does that mean? They are not right after each other, right? So let's say I start at A. Could I go from A to B? All right, because I'm going to connect a line from A to something, but it has to be a non-consecutive vertex. So I could start at A and go to where? Zanai, what'd you say? D. All right, so I could go from A to D. And I'll give you a name for this in a second. I could go from A And again, I'm starting from A. I could go from A to what? D. You already said D. A to C. All right. And then you could go, again, from here to here. I don't think today we are going to do this. No. But we're going to do something in another, it might be another chapter. I can't remember exactly. Everybody's listening to me, okay? So don't just yell stuff out. Let's listen. So there's another chapter we're going to get a lot more involved with this. We're going to do some numbers, we're going to figure out some angles, we're going to figure out a bunch of stuff, okay? But right now, all we're trying to do is just label this stuff, name this stuff. Remember, I've talked about this. Chapter 1 mostly is just about vocabulary. It's about learning new words, okay? It's like a language. Geometry has its own language, and that's what we're trying to do. We're trying to learn another language, basically. All right, so these things right here have a name, and they are called diagonals. So a diagonal is always taken from one point to a non-consecutive vertex. All right, do you understand what I mean by non-consecutive? Consecutive means one right after the other. So non-consecutive means you're going to skip one, right? So look, from A, we skipped F because that would be a consecutive vertex. So we don't draw a line from A to F. That's not a diagonal. That's just one of the sides of our polygon. What I'm going to do is start from A and go to a non-consecutive vertex. So E is not next to F. D is not next to F. C is not next to F, okay? I can't go to B because B is next to A, right? It's consecutive. So those would not be diagonals, but those three right there from point A would be the diagonals. Right? You can do that with all kinds of different, actually, what about a triangle? If you had a triangle, do you have any diagonals of a triangle?
There are none.
There are none, right. Okay, because each vertex would be consecutive, wouldn't it? All right, but starting with a quadrilateral, 4 sides, yeah. All right, and we'll talk about that. A lot more detail. You're going to remember, hopefully, you're going to remember back to this in another chapter. I forget what chapter it is, but another chapter. We talk a lot about this thing right here, the diagonals. So that's pretty important. Okie doke. All right, let's do this. Let's go to triangles now since I brought up triangles. Let's go. What's going on? Let's draw a triangle. I'm just going to like this, and like that. Okay? All right, so here's a triangle. Pretty basic triangle. All right, we got to name this thing. Now, it is a polygon, so I guess I could call it polygon ABC, couldn't I? But it's more specific. We're going to do a lot with triangles, okay? A ton of stuff with triangles. I mean, we have whole chapters just about triangles and nothing else, okay? Yes. We actually have a chapter that's just about right triangles, a whole entire chapter that's just about right triangles. You wouldn't believe how much there is to know about right triangles. There's entire courses that are geared just towards right triangles. Maybe not the whole entire course, but a lot of it. Trigonometry, have you ever heard of that?
Yeah.
Okay, trig, a lot of times we shorten it to that. That's based on triangles. A whole entire course just based on triangles, all right? So weird. It's just 3 sides. You're like, how in the world could you know so much about a triangle? Well, you just wouldn't believe it, but you can, all right? Let's label this thing first. We call it triangle ABC. Again, just like any polygon, you can start at any letter that you wanted. I could have started at letter B. What could you call it if you started at letter B? BCA or BAC, triangle. Okay, so here's a symbol for triangle. Guess what it looks like? A triangle, all right? So it just looks like a little equilateral. That doesn't look so equilateral, but let me, boom, boom. Yeah, it looks a little bit better. So that's the symbol for triangle. Whenever you see this, you say what? Triangle, all right? And let's start with A. We'll call it ABCs, all right? There's a bunch of things you could call it. You could call it ABC. I'm not going to write all these down, but you could go ABC, you could go ACB. You could start at B and go BAC or BCA. You could start at C and go what? CAB or CBA. Any of those would be possible ways to name that triangle. All right? I'll just go super simple and just call it ABC right now. Now let's take a look at this. different color for this. Now, this is important too. All this stuff. You have no idea where we're going to use this, but I've taught this so much that I know exactly where we're going to use this stuff. Okay, so what we're talking about here, just kind of making sure we know what these words mean, is really, really important. So here's something. Look at angle A. What if I asked you, what is the side that's opposite angle A? Okay, side BC, but what is a side? A side is a line what? Line segment. So I would say angle A, you could go either way, is opposite what? Line segment BC, very good. Okay, because BC is not just a line, right? It's a line segment, so we put the line segment. So angle A, you see how it's opposite, right? So BC doesn't have A in it at all, does it? That means it's completely opposite. So what's opposite angle B then? Good. Line segment AC. Because notice, AC doesn't have a B in it, right? And then what else? Angle C. What's opposite angle C? AB. Good. Line segment. AB. And if it's a line segment, you just put the little line without the arrows. And it's really important. It seems pretty basic, all right? But it is important for what we're going to do later on. Okay, we're going to use that all the time. We're going to say, what's opposite this angle, or what angle is opposite this side? Okay, V? Yeah, you could. Now, everybody look, here's the question. You could say AB or BA, that's perfectly fine. You could say line segment AC or line segment CA or BC and CB. What if it was a ray, though? You gotta, right, the first one has to be at the vertex, all right? So that's super important. With lines, with line segments, you can change the order, all right? Even with angles, I've been calling this angle A, but if I use 3 letters, to talk about this angle, how would I name it? I can name it 2 different ways. What is it? Yeah, angle BAC or angle CAB. Look at ABC. If I said angle ABC, is that this one right here? No. How do you know ABC is this one right here? It'd be in the middle, right? Okay, the vertex, let's say it that way. The vertex will always be in the middle, in the center. Everybody got that? I think a couple of you guys on the quiz marked your angles incorrectly because you weren't looking at where the vertex was, all right? The vertex always has to be in the center if you're talking about angles. The triangle, does it matter what order you put the triangle in? Absolutely not, okay? It could be any order, all right, if you're going to name a triangle. All right, we good? Yeah. All right, let's do this. Got another word. Let's go back to the white. All right, and it's called perimeter. We're going to be doing a lot more with this. I keep saying that, but we're just introducing the words right now. We're going to be doing stuff with these words later on. Right now, we're just learning what the words mean. That's basically all it is, all right? So the perimeter, here's how I define it. The book defines it all kinds of different ways. I just say it's the distance around. 2 words. Now, technically, they say it's the distance around a closed figure, all right? Which is true, all right? It narrows it down, but I just like to say it's the distance around. Okay, they say a closed figure, which absolutely is true. It's got to be closed, and if I find the distance around it, then let's do this. Let's make this 5 sides instead of 6. There we go. Oops. Oh, come on. There we go. All right. So if I wanted to find the distance around it, first of all, I'd have to know the lengths of each side, wouldn't I? All right. Now, this doesn't always have to be like a regular polygon. I could do that, right? So now, is every side equal to each other now? No, not necessarily. All right. So how would I find the distance around? I would add up, let's do this, A, B, C, D, E. If I ask you to find the perimeter of it, then I would find the length of what? Okay, let's list all the sides. So AB plus BC plus CD plus, we'll just go alphabetical order, DE plus what? In this one, I'm going to go EA, even though I said alphabetical order. I'm going to go from this one to this one, right? And again, you could have switched the order from AB to BA. It wouldn't make any difference. But basically, what are you just doing, though, to find the perimeter? You're adding them all up. That's right. You just add up all the sides. That's all it is. Everybody with me on that? They give you a little theorem for perimeter. I'm not even going to bother doing that. I think that's a waste of time. I just like to look at it and think about adding them all up. All right? So let's do a couple examples with that. So we're going to actually do a little bit of math. Not a whole lot of math, but just a little bit of math. And let me draw a triangle for you. It may not be to scale, but that's okay. Doesn't have to be to scale. What is going on next door? All right, so let's say somebody measured this, and they measure this to be 4 centimeters. Then they measured this to be 8 centimeters. Like I said, it's probably not to scale, but that's okay. All right? And the question said, find the what? Perimeter, right? Perimeter. All right, so find the perimeter. What does that mean? That means find the distance around the whole thing. So what did we just show before? How do you find the distance around if all the sides are nice and straight like that? Just add them all up. Exactly right. So the math is not hard at all. All right, you look at this, and this is, we talked about this yesterday, but this is kind of what geometry is about. They give you pictures, right? And then they put some numbers in there. They tell you some lengths and stuff like that. And then you have to solve for something in particular. So you have to write out your own equation. In math classes before, they always just gave you the equation, right? Or the problem, and you just solved it. That's all you did. And that's fine. You need to know how to do that. But in geometry, they give you pictures. They give you a situation. They tell you what some things are equal to. And then you got to figure out what something else is equal to by putting it all together and doing some math. So that's what we're doing right here. So what do you do to find the perimeter? Just add up all the sides. Technically, they do have a formula for this, but I just think it's silly to even put that formula because I just think it confuses everybody. So I just add up all the sides. So let's add them up. It'd be what? 4 plus what? 8 plus 10. And that's 12 plus 10 is 22. Do I just put 22 and circle it? Centimeters, right. Everything's in centimeters, okay? So make sure you put the correct units. Because if I just put 22, that could mean what? It could mean 22 feet, 22 miles, 22 inches, 22 meters, okay? So you can't just put 22. You must put the unit, okay? Let's make sure that we always do that. And a lot of times, not all the time, but a lot of times in geometry, things will be measured, right? They'll put the units. Sometimes they don't, sometimes they do. So if they do, we got to make sure that we put the units. Everybody good with that? All right, let's do another one. Pretty easy so far, right? Yeah. Let's make this, yep, 5. Let's do another pentagon. I guess that size is okay, but I'll make it a little bit bigger. Doesn't matter. Okay, so they use 9. We can use anything. And this time they did not put any units. They didn't put centimeters or inches. So do we need units on our answer if they don't give us any units? Nah, because we have no idea if this is 9 millimeters, centimeters, inches, feet, miles, yards, whatever, okay? We don't know. So the question now, there is one thing that they tell you. Well, we know right now. Look, every side is exactly the same, isn't it? Okay? So really, do I have to add them all up? Yeah, just go 9 times 5 because there's 5 sides, right? 1, 2, 3, 4, 5, 5 sides. So I can just go 9 what? Times 5. If you wanted to, I guess you could go 9 plus 9 plus 9 plus 9 plus 9, whatever, okay? But that'd be silly, wouldn't it? So you just go 9 times 5, which is 45. They didn't give you any units here, so you don't have to worry about units. You just put 45 and circle it, and that's all there is to it. Technically, you should put this, perimeter equals. Since they asked you to find the perimeter, put perimeter equals. That's probably better. Did I do that for the last one? Probably not. See, I should have put perimeter equals, and then my final answer should have been 22, P equals 22 centimeters. So that's probably a better way to write the answer. I will not take off points or anything if you don't put the P for perimeter. You remember Mr. Rao from last year? You know who he was? he told me that he does take points off. If you don't write x equals something, like if it was x equals 3, if you just wrote 3, he said he takes point off for not doing that, all right? I've never done that. That's a little harsh, I think, but, he's trying to get everybody to make sure that you understand. Just sticking a 3 there for the answer, well, what is 3? What's equal to 3, right? X is equal to 3. Or in this case, P, the perimeter, is equal to 45. I won't take points off for that, but it's good that you do. All right, let's go to another shape, another two-dimensional figure. Why two-dimensional? Why do they even say, we haven't even talked about that. Why do they call this lesson two-dimensional figures? Because it's flat. That's good. I like that. Okay, it's flat. It doesn't come out. If it was like this and that pentagon also came out, right, that would be three-dimensional, wouldn't it? So this just has like length and width, right? If you had depth, right, or height, then it would come out to be a three-dimensional object. This is just 2 dimensions, all right? And we are going to do eventually 3-dimensional objects, all right, but not right now. We'll do a lot more 2-dimensional stuff. All right, let's talk about a circle. So, I think we talked about a circle already, didn't we? Yeah. What did we say? We did radius, right? Didn't we do radius? Because we kind of talked about the definition of a circle. Yeah, and that was it? That's all we said? All right. So we got a few other things about a circle that we can talk about. We talked about the point in the middle. What do we call that? The center of the circle. So that center is right there. Okay. So we did talk about center. We talked about radius. And that was about it. But let's talk about a couple other things. Let's go red again. So the next thing I'm going to do is a line segment. And it's going to connect any 2 points on the circle. When I say on the circle, what does that mean? Is this point right here, is that on the circle? Yeah, on that white line. It's got to be on that white curvy line right there, okay? That's on the circle. It's not like I cut out a piece of cardboard, a circle on a piece of cardboard, and I could put my finger somewhere inside it. That's not on the circle. The circle itself is actually this line that goes around it. Everybody got that? Okay. So if I connect any 2 points on the circle, let's say from here to here, we give that a name. Now, is that the radius? No. It's not the radius, okay? In fact, a radius, does it connect 2 points on the circle? No. A radius? No, because the center is not considered to be on the circle. A radius connects what? The center of the circle with a point on the circle, right? Any point on the circle, okay? This thing right here connects 2 points that are on the circle. We have a name for that. And it's not probably very familiar at this point in your career, but they call that a chord, C-H-O-R-D, all right? So that's considered to be a chord. Now, a chord is also a what? A line segment. So if I said that, all right? So it's just the name that we call it. We say this thing is a chord. And so you know that both endpoints of that line segment lie on the circle. You know that about that chord, all right? Let's do another one. Now the other one, this next one, is also a chord, but I'll tell you what, let's do a different color. Let's go green. I don't use green that often. So let's start here. Look at this. Now, is that green one a chord?
No, that's a diameter.
But is it a chord?
Yes.
Why? Because it connects 2 points on the circle. That's right. Okay? So it does connect 2 points on the circle. But like you said, Smar said this is a diameter. All right? It is. But it's also a chord. Okay? It's also a chord. So this thing right here is a diameter. Okay? Why is this got a special name called diameter when this red one, it's still a chord. They're both chords. Why is this one got a special name called diameter and that one's not? Why is this not a diameter? That's right. Not the middle. Let's not say middle. What is it? It's the center. It's the center of the circle, okay? So a diameter, listen, a diameter is a chord that does what? That intersects, or that go, how do they say it? It says contains the center, the circle's center, all right? But it goes through the center. That's good enough for us. So diameter is a chord that goes through the center. We good with that? Alrighty. What?
Diameter go like up and down.
Yeah, it could go any direction. I could draw 1,000,000, 2,000,000, 10,000,000, an infinite number, okay, of diameters. Wouldn't have enough time to do that. All right, but that would also be a what? Diameter, okay? What about this little part right here? That would be the radius of the circle, because this would be a radius of the circle. So tell me something about the diameter. I'm getting ahead of myself just a little bit, but we're eventually going to do this, so might as well do it now. 10? 110. Oh, we got more than that. We got like 8 minutes. Oh, I thought you said 3 minutes. Okay, yep. So this is also the radius. So how many radii, that's more than one, how many radii make up a diameter? Those, 2, right. So watch, the diameter is equal to what? 2 radii, all right? So there's a little formula for you. It's not that hard to figure out, right? Everybody good with that? All right, let's talk more about this. We'll keep that same circle up there. It's doing a good job. I'm going to make this a little thicker. Now, what I'm going to talk about is I'm going to go from like this point, this green point, to this green point, but I'm going to go along the circle. So is it going to be a straight line? Is it going to be a line segment? If I travel along the circle, it's going to go from here. Well, let me try to get a little bit better than that. I got shaky hands. Yeah, it's not too bad right there. Okay. It is very good. So we call this thing an arc. All right. Again, we're going to be learning a lot more about this. We're going to be learning that this arc is equal to an inscribed angle, and it's actually equal to the central angle, and it's equal to twice the inscribed angle. We're going to learn that stuff later on. But right now, I just want you to know that that's an arc. All right. So it's just a curve, right? That's a part of the circle. There's a bunch of arcs on here, aren't there? All right. Now, if you were to label the arc, we'll call this DE. All right. If I wanted to label that arc, all right, this is how we do it. We put DE, and again, just like a line segment or a line, it doesn't matter what order you go from D to E or E to D, but here's the arc, right? It's like a little cap to the top of it, okay? So that right there means what? That means arc DE. That's an arrow, supposed to be anyway. I'll just put it looks ugly, but that's an arrow. So DE means it's arc DE, all right? With that little symbol right there, that little symbol means an arc. Everybody good? All right, let's talk about one more thing. We've talked about perimeter. Perimeter is what? Give me 2-word definition of perimeter. The distance around, okay? This next thing is also a perimeter. Let's go blue. But it's the distance around the whole entire circle. And it's a word you probably already know. Shouldn't be brand new to you. If I started at A, all right, I'm going to try. There's no way I'm going to get this to actually match the circle. But watch, I'm just going to go very quickly. If I go all the way, yeah, that's not too bad. It kind of straightens it out a little bit after I let go of it, but that's not too bad. All right, that blue one right there, okay, what do you think we call that? The distance around a whole entire circle. Very good, it's circumference. So you guys were listening at some point in your math career. When did you learn circumference? Any idea? 6th grade? Okay. That's what I was thinking. It's probably in middle school, maybe like a 5th grade thing or middle school, something like that. Okay. Circumference means the distance around a circle. All right. So it's still a perimeter, isn't it? All right. But it's a special type of perimeter. We only use the word circumference when we go around a whole entire circle. All right. That's the only time really we use circumference. And we have a little formula. It is where pi comes in. All right. And I was going to explain pi to you, but Maybe another day I will because I only got 5 minutes. All right. So circumference, I'll put it right here. We use capital C for circumference, is equal to, does anybody remember? We could write it two different ways. Let's write it this way first. Let's write pi times diameter. All right. So that's one way we could write it. But remember what the diameter is. What's the diameter in relationship to the radius? It's 2r, isn't it? You see that? So I could write it C equals pi times what? 2r. But we don't normally write it like that. That looks a little sloppy. So this is the way we would write it. We would write C equals, we usually put the number first. So what do you think it's going to be? 2 what? 2 pi r. All right. So, and some of you are probably thinking, what in the world is pi? Well, probably not. I'm sure you've talked about pi before. What do we know about pi? Okay, it's approximately, see that 2 squiggle thing? It's approximately 3.14. And it keeps on going. I only have it memorized 159. And really, it doesn't, see, and look, I put dot, dot, dot. Why did I put dot, dot, dot? It doesn't have 100. Nope. 1 trillion million. Okay, you're getting closer, but not really. It's got an infinite. Okay, it keeps going forever and ever and ever and ever and ever. All right, and it just never stops. I watched a whole video on YouTube the other day about how they develop pi. Super confusing, but it's a cool video. Maybe one day we'll show it to you just so you can see how much work, listen, how much work it took to just go a couple decimal places. All right, it's amazing. We'll talk about how we develop pi some other time. I just got to do a couple examples, and I would hate to not give you homework for tonight. So
No, that's okay. Is it the homework that was on?
it's the one that's on your sheet, right?
Thursday's homework or Wednesday?
I don't know. What did I give you? I gave you. Oh, I was supposed to give you homework yesterday, wasn't I? I'll just give you Thursday's homework, okay? So I'll just give you Thursday's homework. We'll split it because there's a lot to do if I did it all, okay? But let's do this real quick. We got a circle. Let's make that white. Okay? And here's what they give you. They give you this, which is the what? The radius. And they tell you the circumference is equal to 10 centimeters. And they want you to find, part A, they want you to actually find the radius. So find R. Then part B, well, yeah, that's all we're going to find right now, okay? So let's find R. So how would you do that? Well, we need a formula, right? Do we have a formula with circumference and radius? What is it? Just wrote it down. Good. Okay, now watch very carefully. Now, we could plug in a 10 for C, right? So let's do that. 10 equals what? 2 pi r. If I get r by itself, what do I need to do? Divide by 2 pi. Come over here, divide by 2 pi. Almost done. The radius is, what's 10 divided by 2? It's not 5 pi, it's 5 what? Over pi. And then, if you want to put it into a calculator, you would go 5 over 3.14. Stick that in the calculator. There's no way I could do that in my head. It's 1.59. This is in centimeters, so what's this? Centimeters. So my final answer would be what? Radius equals 1.59 centimeters, and that is the answer. So just do part A. I'll write it down just in case you don't have your lesson plan. So it's pages 35, 36. You're doing 13 to 20 and 31 to 43. So that's plenty to keep you busy. All right, so that's your homework. That's section, we'll call it 16A. All right, so call it 16A. So 13 to 20, 31 to 43. And then that will be due on Monday. Have a good weekend.